Good afternoon, everyone. I hope to keep you awake after lunch. I didn't know how to pitch this, so I've gone for less technical rather than really technical. I wouldn't say I'm an expert. I'm just a simple sailor like most of you, and I do know quite a lot about it from a simple sailor's perspective. Okay. I'm going to talk in sort of 4 sections. Briefly about liquefaction and why ships get into trouble, what we expect from our surveyors before they go, when they're at the vessel, and once loading is complete. Okay, why are ships getting into trouble? What do you think?
Corruption of the loading ports?
Corruption of the loading ports, yes. Perhaps, sometimes.
Wrong data given by the shippers.
Incorrect data by the shippers, yep.
Improper analysis?
Poor analysis at the labs, yep.
Delaying incorrect sampling before doing the analysis.
Sampling procedures incorrect.
Delaying reaching the discharge port for various reasons. Climatic changes.
Well, that can be a problem. There's climatic change is a problem in itself. Incompetent crew. Probably. I would more term it, as a sailor myself, a lack of knowledge. Yeah? A lack of knowledge. Okay. This is the best video of cargo liquefying in a hold that I've come across. Perfect. Some of you may have seen it before. So just this is some solid bulk cargo from some man's back garden in New Zealand. And he's loaded his solid bulk cargo into his cargo hold. And shortly, he's going to take it on a voyage. And you can see that it's definitely solid. He's taking it on a voyage, and it's going on the voyage, and it's getting energy into it. His vibration, his motion. It's only a very short voyage, this. And you can see, particularly around the edges, where the most energy is going into it, it's all starting to settle down. And there he's going over a lumpy bit now. It's force 5. And there we go. He's had a bit of bad weather, a bit more energy's gone in, and the cargo in the hold is liquefied to a large extent. Okay? Not something you want to happen on your ship. Because it does happen on your ship, you get this. Oh, sorry, finger trouble. Which some of you may have seen, particularly if you're from the subcontinent. This is a ship called the Asian Forest that loaded iron ore finds on the west coast of India a few years ago now. And sailed out into this, not really that bad weather, yeah, and quickly developed a dangerous list. They were lucky in this instance, they weren't too far off. This Asian Forest. So that's the result of liquefaction. Shippers don't appreciate the problems ship can face if liquefaction occurs. Yeah? They just don't appreciate this. Some shippers can't carry out the tests sufficiently well, particularly smaller shippers in more remote parts of the world, like Indonesia. The tests themselves may be unsuitable for the cargo being carried. Although the code has got the tests in it, those tests have by and large been developed for substances different than are being shipped at the minute. Not things like iron ore fines, finer substances, mineral concentrates, yeah, and nickel ore. So iron ore fines as it's shipped and nickel ore as it's shipped don't really fall into the category of materials that those tests are good for. Yeah? So there's a decent indication, but they're not brilliant and not developed for specific cargoes. Some shippers don't care. Get it on board, get the ship out to sea, I get me money. They don't care about the life. There's a lack of scientific research into properties of cargoes and how they behave on board. This is perhaps the key fundamental problem here. There's no research, or very little research. Vale, BHP, and Rio Tinto did a big project into iron ore fines, spent collectively about $25 million, and actually got some science behind their new iron ore fines schedule in the code. Seafarers may lack the knowledge or experience to recognize when things could potentially go wrong. Yeah, that's one of the main problems. The information they're getting can be flawed, and they may not be taking sufficient care to ensure unsafe cargo is not loaded. It sounds mad, you know, that your ship can sink and lives can be lost, but some seafarers will turn a blind eye for the going rate of, I believe, some cash in a brown envelope. So sometimes people do things that they shouldn't and put themselves and everybody else into danger. Okay, you guys are, when you're appointed for these types of cargoes, are one of the main barriers to stopping unsafe cargo getting on board, keeping the ship safe, and avoiding nasty commercial disputes. Yeah? And it's you guys are the front line. You can help. You must have the latest information to hand, which probably means the code. You must ensure that the correct safety procedures are being implemented on board. Either you do it yourself or make sure they're being done properly. You'll have to liaise with the shippers to help resolve problems with unsuitable cargo. Hopefully you'll know them. Advise the master appropriately and act as a barrier to unsuitable cargo getting on board. This is crucial. Yeah? Once the cargo's on board, if you get cold feet then, it's too late. Because you're a loading facility, chances are there's no way to get it off. The master will come under enormous pressure. Yeah? The authorities will be down at the ship saying, hey, you can't, that's exported now, you can't take it off. Yeah? So you must not let unsuitable cargo get on board. Not just from the safety aspect, but from the commercial dispute aspect. Doing your homework. The main reference, for good or bad, is the IIMS BC code, which the latest edition has just come out. I don't believe I've got a picture of the latest edition. It should always be your first point of reference. Okay? Because where a dispute occurs, people start quoting sections of the code at you, saying what you should and shouldn't be doing. Is the sampling regime right? How's it being tested? Are your I's dotted and your T's crossed? So you must know what it says in general and about a specific cargo before you turn up. It is useful. There are other sources of information, some of which are produced by people like the Nautical Institute and indeed North of England P&I Club, which may help Okay, the code is an imperfect document. Some cargo is not listed, and perhaps the biggest emission at present is nickel ore, which has been responsible for the deaths of 83 seafarers in the past 5 years. Yeah? And it's not even in the code. So where do you start? It's an imperfect document. New cargo, or cargo from new sources, will take time to make it into the code. The price of commodities is such that stuff that previously would never have been shipped now gets shipped. Yeah? So it may be from a new source, or it may be an entirely new cargo, but it gets shipped. And it will not make it into the code if the competent authority at the load port doesn't decide to put it in. And even if they do, it's going to take minimum 3, maybe as many as 10 years to make it into the code. So in all that time, there's an information vacuum about a cargo and its particular dangers. Yeah? Some schedules may even be misleading. Until recently, there was no schedule for iron ore fines. Okay? There was a schedule for iron ore, and it said, can't liquefy. Okay? And people would load iron ore fines, very often described as iron ore, and think it couldn't liquefy. Chromite ore is described in the code, and it's not described as Group A, but I have it on very good authority that it does in fact liquefy. So, although the code must be your first point of reference, you must treat it with caution. When thinking about liquefaction, I think this is the most important statement in the code. It says in section 7, Group A cargoes contain a certain proportion of small particles and a certain amount of moisture. Anything small enough with enough moisture in is liable to liquefy. So it doesn't matter if it says in the code it's Group C. If it's very small and very wet, there's a chance it might liquefy. You must always exercise caution and use your tools to assess the situation. Once you've done your homework and you know what the cargo is, you'll then maybe get a chance to visit the stockpile or wherever they keep the cargo. You'll want to check what the recent weather's been like. You'll probably know if you live close by. Okay. And if you've been appointed to take samples, you have to follow a sampling regime as per the code or as advised by an expert. Very often, there might be expert scientists, particularly if it's something like nickel ore or iron ore fines, sitting in the background telling you what they want. That's helpful. But if there aren't, you need to follow the sampling regime as laid down in the code. Because if it does come to a dispute, one of the first things they'll say is, well, that sample's not representative. And you have to say, well, I did it as per this code, this section here, and then you'll be okay. You will need the cooperation of the shippers to do that. Their code, their premises, their cargo, but that might not be forthcoming, depending on where you are in the world. So, for instance, if you're going to survey a nickel ore cargo in Indonesia, the shippers may just say no, you can't. Okay. If you're going to Vale's facilities in Brazil, they'll say, well, you can come in, but you can't go in the stockpile because it's absolutely forbidden for our health and safety to go more than 2 meters off the ground. These stockpiles are, 20, 30 meters high. So you've got different reasons there for not being allowed in, but it amounts to the same thing. You haven't been able to go to the stockpile. You must get in there, dig holes, get your hands dirty. Always take your can and always use it. Because this is your first chance to say, this cargo's, alarm bell's going, this cargo's no good, I don't want it going on the ship. Yeah? This is your first chance. If you can, find out about the production, transportation, sampling, and testing processes. Very often, the processes to produce these minerals include things like beneficiation, which involve the cargo being washed, and that introduces moisture into it. Other places, the cargo is deliberately liquefied, so it'll be pumped along pipelines to get from where it's produced to the terminal. So the process itself may introduce lots of moisture. It may be the transportation process, it may be something they do. And if you can establish good relations with shippers, that will help things greatly if it does come to a dispute. You need this background knowledge because it helps you to form an opinion of the cargo to be carried. That's what you get paid for in the end, your opinion. Your main tools. Mark one eyeball. Listening to what's being told, or sometimes listening to the cargo being dropped into the hold. Talking. Getting as much information as you can from as many sources as you can. Using your hands. Pick it up. What's it like? And by doing all those things, your brain will form a sensible opinion on the suitability of that cargo for carriage. Those are a surveyor's tools. Always. Any job. You need to know something about the lab tests. There are three main types described in the code. One is a flow table. Very simple test. The other one is a penetration test, which, again, is reasonably simple. I'll describe them a bit more shortly. And the last one is the Proctor-Fagerberg test, which is more uncommon, but gaining some traction. For years, the flow table test has been the standard. Okay? Very simple process. You put the cargo into this cone-shaped thing here. Cargo goes in there, makes a cone, you turn it, it gets dropped, and if it deforms a certain amount, then you can judge whether it liquefies or not and what the flow moisture point can be. Problems with this is that it's unsuitable for large grain sizes, anything above 7 mil, it's no good, and it's also pretty subjective. It relies on the expertise of the person doing the test. So, lots of problems with that one. Penetration test is a bit more less dependent on the expertise of the person doing the test. Very simple, again, you've got the cargo in a can here, you put in a penetration bit with a weight on the end, and you vibrate the table. This is the vibrating machine here. And once you get a certain level of penetration, then that is judged to be the flow moisture point. The last test, the PF test, Proctor-Fagerberg test, is different again, and it relies on a scientific judgment of the FMP, TML even. Okay, now, it's not that you need to know something about the tests, but unless your company's actually doing them, then you don't need to have the expertise. The thing that's striking to me, this is a sample of results from the same Australian iron ore cargo, done by the different methods. Okay? The flow table gave an FMP of 11.7 and a transportable moisture limit 10.5. Penetration test, FMP 11.2, transportable moisture limit 10.1. Proctor Fagerberg gave TML of 10.3, it doesn't find it an FMP. And the Proctor D, which is a new test for iron ore fines that was developed, gave a somewhat larger TML of 12.3. So some variation there, not much, quite a bit of variation there. But I think for you guys who are actually going out there, or people from your companies who are going out there, the same stuff was, had moisture added to it until it failed the CAM test, and it didn't fail until 14.8, which is way above the lab FMP. Yeah, way above. So, next thing you need to look at when you've arrived at the ship, or even if you can get it beforehand, is the shipper's declaration. What is it? It's just a piece of paper, isn't it? Somebody with a computer said, there you go, type that up, that's shipper's declaration. My cargo is this, it's group A, B, or C, it has these properties. That's what it is. First thing you need to check, does it have all the correct information? Back to the code, section 4.2, gives a standard shipper's declaration and a list of the things that have to be in it. Are they there? If not, why not? Do you know the shippers? Have you worked with them before? Do they produce proper declarations? Do you know the lab? Is the lab any good? Is it connected to the shippers? Can they be pressurized? Check the date, because sometimes the moisture content testing is taking place too far in advance. Check the group. Is it A, B, or C, or a combination? Always do your own TML calculation. The amount of these declarations I've seen where the TML doesn't bear any relation to the FMP would shock you. But it always tells you that something may not be correct. If you're experienced with the cargo, are the figures similar to those you would normally expect, or is something not quite right? And any additional comment or documentation that comes with it must be scrutinized also. Okay, shipping. Once you get to the ship, shipping is a technologically advanced industry these days. Yeah, the bridge here. I mean, the only time I saw a bridge like that when I was overseas, when I was watching Star Trek. Yeah, but these days it's like that. Typical modern engineer, not a speck of oil in sight, just controls everything from afar. You know, there's great vessels like Maersk Triple E class, these Valimax vessels. They're at the limits of modern technology. Yeah. Mining is a similarly technologically advanced industry. This is part of the Pilbara 2 project in Australia, and this is an office that Rio Tinto have in Melbourne, which controls the operations in 7 different mines worldwide from a seat in Melbourne. Technologically advanced stuff. Marine surveying is also a technologically advanced industry. You get to use things like this when they're new, and things like that when they're used. And we'll see technologically advanced CAN test happening. I'm sure many of you have done this. It's a nice little cargo there, iron ore fines, being struck 25 times. Pass, dead dry. That's what you want. But that's as technologically advanced as you get, and of course he's going to pour it out in a minute. Lovely. Lovely. That's what you want. But that is the surveyor's technological tool when he attends the ship. Described in IIMS BC Code, Section 8. You just do exactly what it says on the tin. It is very rough and ready. It's not a substitute for proper testing. Remember back to the slide I showed you with the comparative tests? Yeah? The can test didn't fail until 14.8% moisture, which was a lot higher than the FMPs. But if you do get signs of liquefaction, it is a good indication that there may be problems with the whole parcel. What are they good for? Useful to spot very wet cargo. What's it not good for? There's no alternative to lab testing, and it is not appropriate to accept or reject cargo on the basis of can tests. It can be misleading. You've got that gap between a failed can test and FMP. Yeah? And a lot of people put great store in can tests. It's the only thing you've got, but they can be misleading. And especially when it comes to a dispute, even though the can test may have passed, there's still potential there for you to show that the cargo is over FMP or TML. Yeah. And that's why it comes with this caveat. If free moisture or fluid condition appears, get more lab testing done. You have to do that. Pass or fails at best at FMP and above, and not TML. Are there other options available to you? Yes. I like this one. Splattering. This is a very good indicator of the cargo being over wet. Energy is imparted into the cargo as it drops into the hold and hits the hold of the other cargo, just the same as when the ship's vibrating. So you get splattering because the solid turns into a liquid. Solids don't splash. Yeah? So if you've got splattering, alarm bells should be ringing. So you've got the splattering there, and the cargo is being dropped into the other cargo, and you can see quite clearly, there's going to be problems there. That's unsuitable. Okay, so splattering is one of those things that rings alarm bells. I see it. Any pictures of holes, I go, oh, we've got a problem here. Now, this cargo was loaded into a vessel in Indonesia, and this is pictures at the load port, the splattering. This is it at the discharge. Yep. So splattering helps form your opinion, just as the can test does, just as perusal of the shipper's declaration and the stockpile does. Squeezing. Yeah? Pick the cargo up and give it a squeeze. Does free moisture come out of it? Does it adhere? Does it adhere? Does it go like clay? Or if it just runs through your fingers like dry sand, well, it's dry as anything. Helps form your opinion. Okay. There are other things you can use, like portable moisture content meters and stuff like that. But there are no substitutes for using your eyes and your ears and your hands and your brain to form an opinion on whether or not it's safe. Cargo delivery. This is another classic, particularly if the cargo is being delivered by barges. Are you getting the same cargo at the ship as you expected at the stockpile? It can be extraordinarily difficult on the ground to know. It can be, particularly in some remoter locations in Indonesia. If it's arriving by barge, has it been kept dry in the barge? Have the waves been breaking over? Has significant moisture been added? If it's arriving by barge, have you observed the barge at another vessel arriving and departing loaded? This happens a lot in Indonesia, where one ship rejects and they just send it to the other ship that's at the anchorage. And it'll be bounced around until somebody might accept it. And a lot of times that's when ships get in trouble. They've loaded cargo that's already been rejected, but they haven't been able to know that or haven't kept a close enough eye on things. Short periods of drying doesn't happen. This stuff takes days, weeks, and months to dry. 24 hours will never do it. Are you getting nighttime cargoes and daytime cargoes? Yeah? Just in case you're asleep. Regular and frequent can testing all the time throughout loading. That's at night. You can't be awake, or one person can't be awake for 24/7, so very often you need a second person to attend, or the cooperation of the crew. Reassure the crew you know what you're talking about, which is all in the preparation and the experience. If they think you've got a handle on things, you're more likely to be able to influence the master in the right direction. Appraise the competence and experience of the master and chief mate. Do they know what they're doing? Are they aware of the risks? Are they savvy? Or are they just going to allow the pressure that might be put on them by the shipper or by the charterer to let them make decisions that may not be correct? Advise and support throughout. When you're there, educate the crew in can testing, what the risks are, because the next time you have to work with them, it'll make it easier. Reporting, regular and accurate. Your opinion of the cargo. Millions, we like HD photos, yeah? Because if we need to show them to an expert, they want very high definition photos so that they can try and make judgment. If they get grainy stuff, they just say, I can't, Videos are great, especially if you can see splattering and stuff like that. Full details, especially when cargo's been rejected. Liaise with the experts if appointed, and just keep the information flowing. After loading is complete, because you guys have been there, the vessel will have sailed safely to its destination without incident, as you have helped ensure liquefaction has not occurred. That's the result. Unfortunately, it doesn't always happen like that. The worst result is for overweight cargo to be allowed on board. Like this. This is cargo on one of north-centered vessels en route from Indonesia to China. And a crew member took this, apologize for the poor quality, with his video phone. And you'll see it. This ship made it to Port of Refuge. Yeah? It made it. Lots of others haven't.
Colin, are you happy to take questions?
Yes, I'm finished now, Bridget. There may be no way to get off. There will be a nasty commercial dispute, and your principals will be asking why they paid you and telling others what happened. Most shippers are genuine. The vast majority of these cargoes move without incident. You're just there for the few times. And don't get complacent. Keep alert. Keep doing the things you know you should always do. Form an opinion. Give an honest opinion. That's what we want. Even if it's not what the owner might not want to hear, unfortunately, that's sometimes what it is. Any questions?
Just a quick one. I mean, you mentioned on your presentation that a failed CAN test is not enough evidence to reject the cargo.
It is. A passed CAN test isn't necessarily sufficient evidence to accept a cargo. If you feel if a CAN test fails, retest, goes to your lab, yeah. And you should reject any cargo until, you know, if you get a barge and it fails, just send it away. Yeah. Anything else? I hope that was the right level, chaps. I didn't want to make it too technical.
Very
Exactly,
interesting.
you know.
And I've got some copies of Seaways with